You just had classwork. I haven't looked at that yet, but I will. I promise I was supposed to give it back today, and I'm sorry. I didn't. I know, I just talked 100 miles an hour. I'm sorry. But we're going to talk about domain and range for just a second. You should have done this in all your math classes previously, so that part should be a review, but I'm going to show you a new way to write it. Before I do, tell me what domain means. Something with the X. You're exactly right. Domain describes X. How about range? The Y. Good job. So before we get into the actual domain and range, I want to introduce you to something new, a new way to write. Before, what are y'all laughing at? Are y'all laughing at me? I feel like there's some joke that I'm not in on. I know, y'all are just laughing. We're going to write domain and range in what we call interval notation. Now, before, if you needed to say X was greater than, let's say, 3, okay? That's what we call an inequality, right? Y'all know about inequality? And if we think about it on a number line, here is 3, then I have to think about, is that dot going to be open or closed? You tell me. Open. Why is it open? There's no or equal to, right? It can't actually be 3, but it can be really close to 3, but it can't be 3. And then greater than goes which way? To the right. Okay. But there's another way to write this. These are two different ways. This is graph. This is inequality notation. But there's also interval notation, and that's what we'll be moving to, is interval notation. So here's what I want you to think about. We know that there's a difference if this was X is greater than or equal to 3. That would mean that the dot is bubbled in because it includes it, right? So there's a difference in non-inclusive and inclusive. And so the same with interval notation. And I think I'll just throw this out there and then we'll jump in and look. If it's not included, we're going to use parentheses. If it is included, we're going to use a bracket. Bless you. Y'all are just giggly today. What is going on? Okay. And what we're going to do is we're going to make this a range of numbers. So we're going to say either bracket or parenthesis. We're going to have some low value, and then we're going to put a comma, and we're going to put the high value. So we're going to say that X has to be between these two numbers. Now, if I go forever in one direction, in other words, if this gets really big, how do we say really big in math? Infinity. Have y'all seen this before? Have you really? I'm sitting here. Okay, no. Some of you haven't, some of you haven't. It's okay. Don't be embarrassed. I'm going to say infinity this way. If I go the other way, what do you think that would be? Negative infinity. All right, so that's a whole lot of little pieces here, there, and yonder that I'm fixing to pull together to one big concept now. If I want to say that X is greater than, we'll say greater than or equal to 3. Because it's or equal to, I'm going to use a bracket. We'll put that on first. But what's the smallest or the lowest value that X can be? 3. Then I'm going to do a comma. What's the biggest X could be? Infinity. I'm going to put a bracket on the 3 because I'm doing this or equal to, right? And infinities always get a parenthesis because you can't actually be infinity. That's more of a concept, right? Say right, because that's right. Okay, thank you. So X is greater than or equal to 3 in interval notation would look like this. Does that make sense? You think you've done it before? Okay, let's see if you can do it. Tell me in interval notation what that would look like. Take a minute, don't blurt it out, but take a minute and try it. Smallest to biggest, lowest to highest. What's the lowest it can be? And if you need to put it on a number line as you're getting used to this, that's okay. -2 is the smallest, right? And then it goes up to, oh, no. Negative infinity, that's right. And then it goes up to -2. In this case, -2 is the biggest it can be, right? Because it's a less than. Think about it on a number line. Here's -2, and it's like this. Do I get a bracket or a parenthesis on the infinity? Parenthesis. They're both parentheses. That's exactly right. What if, you know, a lot of times we say x could be anything in the whole world, right? So we say something like all real numbers. How would we write that in interval notation? That's all. How would you say all? Think about that number line. If I could be anything, what's the smallest I could be? Close. Negative infinity. And then I could go all the way up until what? Infinity. So if you could be anything in the whole wide world, there are no restrictions. It's just negative infinity to infinity. Now, sometimes I have more than one part. Like maybe I have this compound inequality. Let's see if you remember compound inequality. That looks like this. Could you write that in interval notation? Do it. What's the smallest? -2. What's the biggest? First one, bracket or parenthesis. There you go. Bracket or parenthesis on the last one. Does everybody see where we're going with this and what we're doing? Now, sometimes you might have to join more than one piece together. In other words, maybe I said that, well, and these are what we called and inequalities whenever we did compound inequalities. Then you had something called the or ones. They go off in both directions. Do y'all remember those? Like I might say that x is less than, I don't know, 5, or x could be greater than, let's say less than or equal to, or x could be greater than 10. And so on a number line, this is what it would look like. Here's 5, here's 10. I could be less than or greater than. So I need to join these two pieces together. The way I do that in interval notation is with a U. And it just means, I don't know that they keep using an intersection of sets anymore. They should. But it just means join these pieces together. So anytime I want to join two things together, I join it with a U. So I say that because in this, what's the smallest value x could ever be? Negative infinity, right? See how it's going this way? So it could be negative infinity, but once I get to 5, I have to stop, right? So I stop by putting that value there. So I say from negative infinity to 5, and then what I do is I put a U in here, and I say, okay, now what I'm going to do is I'm going to stop, but I'm going to pick back up where? At 10. And then I'm going to keep going until I get to, oops, terrible infinity, until I get to infinity. Both of these with Does that make sense, how I joined those two together? So if there's two pieces you need to join together, you do it with a U. One other little thing that comes up with Gemini range a lot, and that is, what if, because this happens sometimes, what if I could be anything in the whole world except for one particular number? Like maybe I said x could be anything except for 2. X can't be 2. How could I say that in interval notation? And again, if you have to picture it on a number line, sometimes that helps. Any idea? I can't be 2. How do I not include one specific value? Right. And on a number line, that would look like what? An open dot, right? So I'm saying I could be anything on this number line except for 2. So what's the smallest I could be? Negative infinity. And then I go up until what? 2 and I stop. Can I be 2? No. So I'm going to use a parenthesis because I can't actually be it. If I can be it, I'm going to do a bracket. But if I can't be it, I'm going to put a 2. I've got 2 pieces here, so I need to join it together. So I'm going to do my U, but where do I pick up? Still at 2. Because if I still put 2 with a parenthesis, it says, oh, you can't be 2, but you can be 2.000000001, right? But I can't be actually 2. And then I go up until what? Infinity. All right, if you have not seen interval notation before, what do you think? All right, let's do some practice with some graphs because I showed you all that so that you can do domain and range on graphs. This is where students struggle. Going back to this domain and range, we said that domain describes X and range describes Y. I'm going to go a little bit further with that and say that for domain, we're looking at the graph left to right. And for range, we're looking at that graph from the bottom up. I always say bottom up. Bottom to top. Since Y gets smaller down, we go from the lowest point up to the highest point. So let me give you a little graph and let's see if we can do some domain and range work with it. Let's say I have the graph. Let's do a line segment to start with. Let's say this point is -2, -1. And this point is 1, 2. So I got this little line, this little piece of a line, right? Domain is everything that X can be. So left to right, what is the domain of this line segment? What's the furthest left it goes? -2. So I'm looking at X's. Can it be -2? Yep, because it's a solid dot, right? So since it can be, I need to do a what? Close bracket. And then it goes until what? 1. Can it be 1? No. It's open, right? That's okay. Bracket or parenthesis on 1. Parenthesis. Okay, well, what about the range? -1, because that's the lowest it goes for the Y, right? Is it a bracket or a parenthesis? Bracket. And then up to the highest. Bracket or parenthesis? Domain and range. Yes, no, maybe so. This is what we've been working with. Done a lot of graphing with parabolas. What is the domain of this parabola? Domain is X, and X is left to right, yes? Keep going. Even bigger, more. Okay. Negative infinity to infinity. Why? It keeps going. So left to right. If I move, because this parabola, really what it's doing, if you think about it, right, as it's going up, it's also inching out. Do you agree with that? Because if I put in 1, I'm over here. If I put in 2, it's still moving outward as it goes upward. It never just goes straight upward. So x could be anything in the whole wide world, left to right. It might end up really, really high, but it's still going to be there left to right. Is everybody in agreement there? So negative infinity to infinity. And in fact, all quadratics have this domain. And that's important because I'm going to make you go back and do your domain and range on all your quadratics. Well, you already know that the domain is going to be the same on every single one. It's always going to be negative infinity. Y'all okay with that? The range is what's going to be different. Bottoms up. 2 to infinity. It starts at 2. It goes up forever. Do I need a bracket or a parenthesis on 2? A bracket. It's always going to be a bracket because that point is always included, right? That's my vertex on this one. And in fact, that's what that's always going to be, is the y part of your vertex. Always. Well, it depends on if it opens up or down. Let me show you one that goes down. I don't want to go too fast if y'all are still. You take just a second and do the domain and range of that. What's your domain? There you go. Everybody should get that right because it's the same for all of them. How about the range? Bottoms up. What's the lowest that graph ever goes? Negative infinity, right? Because it goes down forever. So from negative infinity, and where does it stop? At 0. Bracket or parentheses? Always. What do you think? Not too terrible?